let's get started. So the first session, so tonight we're going over all the strategies and then but I like to always go over challenge problems. So I don't know how much of you are familiar, but the math section of the SAT is going to have two 22 question modules. And the first module is kind of like a medium level. It's got some easy, medium, and hard problems. And then it's adaptive. So if you do really well in the first section, then the second section is much harder. And if you don't do as well, then the second section is easier. But you want the hard section because when you get the hard section, you're going to be like in a higher score range. So the second section has a lot of hard problems, which is why I want to go over like each week, just kind of introduce you to as many of these like really hard SAT problems that I could find. So let's kind of get started here. So this first one is an inscribed, a circle is inscribed in a square, and they're telling us that this side length is x plus 2. Which immediately tells me that the radius, because anytime you have a circle, you really want to know the radius. That's half of that. So half of that is going to be x plus 2 over 2. And then it wants the area of the shaded region. So just in general, the way we would find the area of the shaded region here is just the area of the square and then minus the area of the circle. Well, the area of the square is just the side length squared. So that's going to be x plus 2 squared, which I'm going to write it like this because if you write it as x plus 2 squared, some of you may just know what that is. Some of you may think that it's x squared plus 4, and it's not. So that's a mistake that I see a lot. But if you write it out like this, then we might remember to FOIL appropriately. So that's the area of the square. Now, the area of the circle, this is a formula that they give you on the reference sheet, but the area of a circle is pi r squared. So that means we have pi times the radius squared. So again, I'm going to do two things here. I'm going to make the radius actually, if I divide each of these by 2, that's like saying 1 half x plus 1, just so that I don't have to deal with like squaring the whole fraction. So again, x over 2 is the same as 1 half x, and 2 over 2 is 1. And then since I'm squaring it, I'm going to write it like this. Again, just so that we do FOIL appropriately. Now, again, if you know the quick way to do that, then you should do that. So if I do the area of the square, again, if I kind of look at it as FOIL, that's x times x, which is x squared. And then x times 2 is 2x. And then 2 times x is 2x. And then 2 times 2 is 4, which becomes x squared plus 4x plus 4. So some of you may be able to go directly to that, and that's great. All right, if you know how to square a binomial, you might be able to go straight to x squared plus 4x plus 4. All right, so I'm going to leave that there. Now I'm going to go do this one. So I'm going to leave the pi out for a second. So again, if I do FOIL, a half x times half x is 1/4 x squared. And then a half x times 1 is a half x. And then 1 times a half x is another half x. And then 1 times 1 is 1. Okay, so now that becomes 1/4 x squared, and a half plus a half is 1. So that's plus x, and then plus 1. All right. So I have not forgotten the pi. So I'm going to subtract the pi and then all this in parentheses. And finally, this is the last step that I'm going to do. So I have x squared plus 4x plus 4. And then I'm going to distribute the pi and the negative. This is a negative pi that's being distributed. So that's minus 1/4 pi x squared. And then minus pi x. And then, oops, it's not plus. Let me get rid of that. So again, minus pi x and then minus pi. So that's where I'm going to stop the problem and look for the answer. So none of these are like terms. These all have pi in it and these don't. So clearly A and D just don't match. And then if you kind of search through and match it term for term, so I'm not going to waste my time writing it in the same order that they have it, we can see that B is the answer. This 1/4 pi x squared kind of gives it away, and C doesn't have that. Okay. So again, I think a very challenging problem. There might be some quicker ways to do it. We're going to learn a strategy later that maybe could apply, but I just wanted to go over this way, again, to go over more of the algebra. So does anybody have a question on and about any of that? Okay. So the other challenge problem is a proportion, which again, this one has another strategy that we could apply, but I am going to save that for later when we actually talk about all the strategies. Um, so this one, we got a 5 gallon bucket of paint that costs $D and will cover 1,800 square feet of surface area. Um, and then if a room has K square feet, what's the total cost to paint three such rooms? All right. So the first thing is the bucket of paint. So cost D dollars. So that means D dollars is going to get us 1,800 square feet. Okay. So it doesn't really matter the number of gallons. That's kind of just an extra number in the problem. And this is going to be a proportion problem. So this is going to be the same as, so since I put dollars on top, I want to know what can I get for T dollars. So I'm also going to put T on top. And then on the bottom is the amount that we want to spend T dollars on, which is a room with K square feet. And there are three of those rooms. So that's 3K. All right, so this is the more like mathematical way to do it. You just set up a proportion. You could solve this a couple different ways. When I have proportions, I like to just cross multiply. So here I'll get 3 d times k. And then if I cross multiply, or if I multiply this way, I get 1,800 t. And then our goal is to get t by itself. So divide everything by 1,800. And again, this isn't one of the strategies that I'm going to go over tonight. This is just a very, very general strategy. If possible, just stop doing the problem as early as you can and then choose the answer. You don't get credit for any work. This isn't school where you have to like show all of your work. I've gotten T by itself. I would stop here and hopefully we know that 3 over 1,800 would reduce to 1 over 600. Notice all the answers have a DK in the numerator. That's this. So the only answer that really works is this. I don't know why this wasn't lettered, but this would be letter B. And if you have any issues with fractions, that's something that we can talk about later that you could just do in Desmos. Desmos will just reduce fractions for you. Okay, so that's our two challenge problems. So we always start with two of those. They don't necessarily have to do with the lesson. Again, they're just a bunch of really hard problems that I've come across for this new digital SAT. Does anybody have any questions about any of those? All right. So let's take a look at our problems for the night. So there are 12 problems, and I broke them up into 4 different strategies that could apply to a lot of different types of problems. So again, we'll refer back to these each week. Um, So one type of strategy is to just use the answer choices. So obviously that only works on a multiple choice. Your modules will be split up into some mostly multiple choice and some open-ended that'll be kind of like sprinkled in throughout. But most of them will be multiple choice. So if you have a problem, so here they have a circle problem. It just says which of the following points lie on the circumference of the circle. So what we basically have to do is just check each answer. When you could also use Desmos, but we're going to talk about Desmos later. So right now, I just want to go over the idea of how you check answers. So basically, just start with one of the answer choices until you find one that works, and once you find one that works, you're done. Um, so, and also for something to lie on the circumference of the circle, it just means it has to satisfy this equation. This equation represents all the points that are on the circle. So I will just start with this. So I'm going to plug in 3 for x. I'm going to write this out, but you might be able to just like do this in your head pretty quickly. And then I'm plugging in -2 for y. And then this part I'm going to do in my head. And then I need this to equal 9. All right. Well, 3 minus 6 is -3, and -3 squared is 9. So that's not looking good because -2 plus 1 is -1 squared is 1, and 9 plus 1 is not 9. So that answer is gone. And then if I look at the next one, my x here is 3 again, right? So I already know that this is 9. And then I have 1 plus 1 squared. Well, again, that's not going to give me 9 because 9 plus anything other than 0 is not going to be 9. So that doesn't work. And then when I plug in 6, this one looks good because 6 minus 6 is 0. And then I'm plugging in 2 for y, and 2 plus 1 is 3, and 3 squared is 9. All right, so these two didn't work, but this one does. Once you find the answer, you're done. This will be different in another strategy that we do later. But when you're checking answers, once you find the answer, you're done. There's no way that there's not more than one answer to the problem. So this was a kind of problem where, other than like plugging it into Desmos, we really didn't have much of an option but to check our answers. Um, but let's take a look at one where you could solve another way, but it is really easy to just check your answers. So one kind of tip is don't solve any radical equations the way you would in school because it's going to take too long. And for another reason. First of all, you'd have to square both sides, get everything to one side, factor, likely get two answers, and then one of those answers is probably what they call extraneous, which means it doesn't work. So then you're back to plugging in the answers anyway. So you're like wasting a lot of time. So I would only solve equations that are pretty easy to solve, like some simple linear equations or like a quadratic equation that like a quadratic equation that is just easily factorable. Um, so that's kind of the rule that I would go by. So if you have a radical equation, you really have two good options. Either Desmos, which again we're going to get to Desmos later, or just plug in your answers. I actually think this one you could do more quickly than even the amount of time it takes to type into Desmos because the first two answers make this side negative. -1 minus 3 and 1 minus 3 are negative. And when you do the square root of a number, it's always going to be positive. So these answers just don't make any sense. Then you try 5. 5 minus 3 is 2. And on the other side, you get 5 plus 17 is 22. And the square root of 22 is definitely not 2. So once you've eliminated the first three, the answer just has to be D. You can certainly check it. 8 minus 3 is 5. And 8 plus 17 is 25. And the square root of 25 is 5. All right. So kind of the takeaway is there just don't waste your time solving any radical equations. They they just take too long anyway. All the algebra that's involved in them, you definitely need to know. And none of the strategies that we're doing are ever really like a telling you to not know the concepts. You definitely need to know the concepts because when the problems get harder, they have clever ways of making it so that checking the answers isn't going to be possible. So again, we'll talk about those as we go. But these are to try to find, the quickest way to do these problems. Okay. So number 3 is one that it's a little bit tricky on how we're going to use our answers, but I'll show you kind of like a systematic way that I did it. You can definitely do this algebraically. I just feel like students can get a little bit confused on these age problems. So the way that I kind of did it was I kind of ignored this at first. It just said find Vera's age in 5 years. So what I'm really concerned with is like what's Vera's age right now. So what I did was I just subtracted 5 from all these just because I could do that really quickly. So if any one of these was the answer, if that was her age in 5 years, then her current age would be 5 years less than that. And then I was like, okay, then what would Nora's age be right now? Well, Nora's 10 years older than Vera. So I can really easily just add 10 to all of these. So these are all the possibilities of Vera and Nora's age right now. Now, all I'm going to do is I'm going to kind of execute this sentence, but I'm going to kind of do it in my head. So in 3 years, well, in 3 years, they'll each be 3 years older than what I've listed here in blue. And I want Nora to be twice as old as Vera. Um, so in 3 years, Vera will be 5 and Nora will be 15. That doesn't work. In 3 years, Vera will be 7 and Nora will be 17. Doesn't work. In 3 years, Vera will be 8 and Nora will be 18. Doesn't work. This one's clearly the answer, but in 3 years, Vera will be 10 and Nora will be 20, and 20 is twice as old. So that's just an example of like a systematic way to get around having to do like a systems of equations. And there's nothing wrong. If you can just come up with the system quickly, then that's the way that you should do it. Very rarely will anything that I do be telling you that you like have to do a problem a certain way. It all depends on how quickly people do things and what they know and what they've been exposed to. These are all just different like options that you have. And ultimately, when you take the test, you've got to kind of put that all together. There should be some problems that you use the answers, some that you use Desmos, others that you pick your own values, others that you just do the way you learned in school. And kind of combining those is going to be the best approach. But again, it's different for everybody. So before we move on, does anybody have any questions or anything they want me to clarify about those three problems and just like checking your answers in general? Okay. All right, and let's move on. So next strategy is going to be choosing your own values to make a problem a little bit easier. We could have done this on the challenge problems, but I wanted to save it for this. So after biking K kilometers, she has 8 kilometers left, which represents the percentage. So these problems are good whenever you read a problem and you kind of think in your head, I wish they just told me what that was. Like what makes this problem difficult is that they didn't tell us what K was, and then K is in every answer. So when that happens, and these ones can get harder where there's even more unknowns, and that's like a type of problem where you can do this. So just give K an easy value and then think about what the problem is. And if you pick a nice, easy value, it should be pretty easy to do in your head. So what I did was I made K 2 because if K is 2, after biking 2 kilometers of the total distance, she has 8 left. Well, if she has, if she biked 2 and has 8 left, that's a total of 10. That's why I chose 2 because 10 is a nice, easy number to work with when we're dealing with percentages. So then the question says, so then what you want to do after you pick your value, answer the question. Which of the following represents the percentage of the trail she still has to cover? Well, she has 8 left out of 10, which is, 0.8, which what's the percentage? That's 80%. So basically what I did was I made K2, that led to an answer of 80%. So now I just plug in 2 to the answers, and the one that gives me 80 is the correct answer. Now, if someone picked a different value for whatever reason they wanted to do, they found another number easier, or they just didn't think too much about it. They just picked any number because it should still work. they'll have a different number here, but they'll also be plugging in a different value of k. And the correct answer will still lead to their answer. Okay, so this works if as long as it's a problem where this applies to, it's going to work for any value you pick. But if you can think a little bit about it, there's definitely values that'll be easier than others. Okay, so when we did the plug in the answer choices, once we got the right answer, we were done. That doesn't apply here because sometimes a wrong answer can be right for one specific value. So in that case, you'd have to pick a new value. So what you have to do is make sure that there are three wrong answers and one right answer. So if I run through these, again, I'm trying to get 80 as an answer. This is 200. All I'm doing is I'm replacing k with 2. This is 200 over 8. That's definitely not 80. You can check in your calculator. 800 over 2. Again, definitely not 80. 800 over 10. That is 80. But I'm just going to do this and real quick make sure this is wrong. So this is 200 over 10. So again, that is wrong. So this is the answer. All right. So again, there are times when a right answer is correct for every value, but there could be a wrong answer that just happens to look right for the one value that you picked. If that happens, pick a new value for the two that are left and kind of like break the tie. Sometimes the advice I hear is people say to like never pick 0 or 1 because that tends to happen more because 0 and 1 are kind of special numbers. I think that there are times when 0 or 1 can be very useful, but for a general rule, that's probably a pretty decent rule. So, but again, I just tried to pick a number that would be really easy, so to make it go to 10. Okay, so next one. Again, we're focusing on the idea of choosing your own values to make a problem easier. So I tried to find different types that would fit that. It doesn't mean that it's the best way to do it. So if you're there thinking like, oh, I would have done this differently, as long as you get the right answer, that's totally fine. Um, so this one is another good one where you can pick values, where you have some equation that has two variables or maybe even more in it, and they want the value of some expression that has more than one variable in it. So what you can do, again, there's a school way, like algebraic way to do this, but another option is to just say, well, let me just come up with values of C and D that make this true. Now you can't just pick any values you want because it has to make this true. So what I did was I made C1, yeah, and D 16. Because if C is 1 and D is 16, that gives me 4 over 16, which is 1/4. So again, you can't just pick any values you want. You have to make sure it satisfies this. But once it does, this part is so easy. You just plug it in, and 16 over 1 is 16. So if you pick easy values, then the problem just becomes a lot easier. I guess that's obvious. But um, again, you can like cross multiply and get d by itself and substitute. And again, we're all going to get to 16. But it's just to kind of show you that there's different ways, and sometimes it's the best way to do it or the quickest way. And other times it's just kind of like a bailout way because there's a lot of concepts that you have to know for the SAT. So if you like forget a concept, hopefully these strategies can be helpful to be like, okay, well, at least I can try this if I like forget like a very specific concept because there's a lot of them that you have to know for the SAT. Okay. All right, here's a really good one to pick values. Up here, definitely algebraically, I probably could have done it in the same amount of time, but I think this one is a really good one to choose values. And there's a really good value to choose that might not be like might not be a number you would use on other problems. So what we have is this idea of these two expressions are equivalent, okay? And we want to know the value of b. So the idea is for any value of x that we choose, except hopefully we can see, except for 3, because you can't divide by 0, what If we make all the x's a certain value, then all we're doing is figuring out what b equals. All right. So what I did, a lot of times people might choose 0. I think that will work here. But what I decided to do was choose x equals 4. And the reason I did that was because that would make these denominators just 1. And that just, to me, makes the problem a lot easier. So I replace each x with 4. Um, and if you want, just use a calculator. Don't do, I might do some of this in my head, but don't do the stuff in your head if you're not like super, super quick, because there's no reason, again, you have a calculator available. You can have your own and you can use Desmos. You want to do these problems, as quickly as possible. So you don't get any extra points for doing stuff in your head. But here we go. 4 squared 16 times 2. So this is 32 plus 24 minus 11. And again, since I picked 4, this just goes to 1. So I don't have to worry about it. This is 8 plus 12 plus b, because again, b divided by 1 is just b. So that's why in my opinion, it was easy to pick 4, because then I didn't have to worry about those denominators. And now if I give you this problem, this is a super simple problem. So it's a complicated looking problem that just looks way easier once we choose our own value. Um, this was 32 plus 24, so 56 minus 11, so 45. And then this is 8 plus 12 is 20 plus b. So again, I would stop here and just know that I would take 20 away from each side, and that b would just have to be 25. All right. So again, no one's going to see that you did this. And I know that we're used to, kind of programmed to do that because of school. But the earlier you can stop in a problem and then just put the answer, obviously you'll be working on scrap paper and click the answer on the computer. Again, that just saves time. But you don't want to do it too early. You have to know yourself and know how well you are with mental math. If you have to do all the work, then that's better than trying to, do more in your head early and then get the wrong answer. Okay. So this leads to our third strategy, which is I just call skimming the text. It's just don't read every word on certain problems. There are some problems where you kind of do. But 7 and 8 are similar in the sense that when I see an equation, that kind of jumps out at me. All right. So I have this equation, um, and the equation is in slope intercept form. All right. So we definitely need to know slope intercept form, y equals mx plus b. And then what the SAT does is they just disguise this stuff by changing around all the letters. So they just made Y, C, and X, S. Don't let that fool you. You just see something in this form. There's not many forms on the SAT. There's linear, there's quadratic, there's some exponential, um, and then circles. But there's not that many forms. So we should be able to recognize this is linear. And we should know that the number in this position is the slope, and the number in this position is the y-intercept. All right, so these are all things that we definitely need to know those concepts. But then once just go to the question. What does the number 29.99 represent? So that's the slope. So all we have to do is find an answer that gives us an impression of slope. If there's two of them, then we may have to go back and read more of the problem. But honestly, the word per, slope is a rate, all right? This one looks good. But again, just to make sure, initial fee, that does not look good. Initial is actually the y-intercept. So the y-intercept is the starting value or the initial or the beginning. So that's just, they're trying to get us to mix that up. The total amount, the slope wouldn't represent total, or just the number of tickets purchased. Again, without reading the problem, we can just jump back. S is the number of tickets, that's not the slope. So the answer is A, because it's the only one that even resembles something that's talking about slope. So look for the word per, look for rate, increase, decrease. They're different words that could mean slope. All right. Now, again, there are harder problems where we have to kind of go back and read more. But what we do is we attack it from, let me just do the least amount of reading and see if I can get the answer. And there are problems where that'll work. And then again, you're kind of banking time for the harder problems. So then I wanted to do this one as well, like at the same time, because you just look at this and you just have to notice, okay, I have an equation that looks like slope intercept form, and they want to know what the 75 represents. All right, well, we kind of just talked about that. That is the b value, which is the y-intercept. The y-intercept is the initial value or the value when the input is 0. So the y-intercept is when x is 0. Well, the input here is h. Um, so again, if you look at it like charge per hour, that's a slope concept. The only one that looks anything like it would be a y-intercept is A. It's this one-time fee. All right. So again, without really reading the problem, we can figure that out. So a one-time fee, an initial value, something you pay up front, that they're all things that a y-intercept would typically be. Now, again, in a harder problem, you might have two that are similar, and then we'd have to go back and read more. But the point of this was to have you just kind of get in the habit of, if I see a slope intercept form word problem, I might be able to do it without really reading very much. Okay. Number 9. So this one is not like that, but it's still this idea of this isn't even skimming the text. This is don't read anything at all. These are called literal equations. Not that you necessarily need to know that that's what they're called, but just so like we have the vocabulary to talk about them. So anytime you have a literal equation, what a literal equation is it an equation that has a lot of different variables in it. It's typically like a formula from like some other area of math, or some math related science usually. And then they want you to solve for one of the variables. So you're rearranging it to get one of the variables by itself. So there's no shortcut in the sense of like we're going to have to do the algebra, but what we don't have to do is waste any time reading this. Because if I see an equation and I see four answer choices that all have r equals, then it's pretty obvious that I just need to get r by itself. If I read this, then I'm starting to think about a car depreciating and an annual rate. You read it a couple times, maybe it doesn't make any sense to you, but the reality is it doesn't need to. So just don't even read it at all. Now, there are certain problems where you need to read very closely, and we'll get to those. But on these specific types of problems, they're just explaining all this. And then sometimes they'll do it in the sense that it'll be like I don't know, be some equation from like physics or chemistry or biology or something. And then we read, and then we think that we were supposed to know something about that equation, but you're not. These are not equations that you need to know anything about. What you need to know is how to do the algebra to isolate one of the variables. So again, keeping yourself from reading it is just going to save time and keep you from getting confused because you don't need to know anything about depreciating or annual rates in this problem. What you need to know how to do is start with the formula or equation, and you need to be able to rearrange it to get r by itself and do it, I guess, as quickly as possible or in the least number of steps. So the first thing that I would do is divide everything by p. All right. So again, I am trying to isolate r. So I'm going to divide by p. So I'm going to write it out, but if you have, if you want to do it all, do a couple steps in one, again, to save time, that's fine. But I just want to write it out so we can clearly see what's going on. Now, to get to r, I need to get rid of the t. Well, the t is a power. So the opposite of a power is a root. So I'm going to do like the t root of each, or the tth root of each side. Um, so just imagine again, if that's confusing, if this were squared, you'd take the square root of each side. If it were cubed, you'd take the cube root of each side. And look at the answers to help you. You see how you have like a t root of each one? So that can kind of give you an idea of what you should be doing. Well, that cancels out the t, so I'm left with 1 minus r. And our goal is to get r by itself. I would rather actually do it this way. I don't want there to be, I want a positive r, not a negative r. So I'm actually going to add the r to this side. You definitely could do this a different way. I just see when doing it the other way, I see more mistakes. And then this is where I would stop. So to get r by itself, I want this teeth root of v over p to go to the other side. So I should start with a 1 and I should be subtracting it. Um, and that is answer choice A. D looks pretty close, but D made the mistake of not rooting the whole thing, or maybe dividing by P later when you should have done it first. Okay. So again, this problem already has a decent amount of steps, so don't add that. Add steps by like reading the problem. But I just want to again say that I don't want anybody going into this thinking that I don't have to read it all. There are definitely problems where reading is going to be super important. Um, and sometimes you might even have to read all of it, but sometimes you only have to read part of it, and other times you don't have to read any of it. So on those problems, if you can do that, again, you're just saving time. Because the second hard section, which you hope to get, is I've heard from a lot of students is very challenging on time because there's a lot of hard problems. So in the beginning of that section, you really want to kind of be able to take advantage of the easier problems and do them quickly so that you have more time later. All right. So now we're going to move on to our last three problems. And this strategy, our fourth strategy, is using Desmos. The Desmos should be a really, really big part of how you take the digital SAT. So what I'm going to do here is we're going to read the problem, talk about how we're going to use Desmos, and then I'm just going to share my Desmos screen and then do the rest of the problem and then kind of come back. So we are solving a quadratic equation. You can do this by getting everything to one side and factoring, right? So that is, you definitely should know how to do that and you should know how to factor for the SAT, but it might be quicker to solve this using Desmos. So there's really like kind of two different ways that we could use Desmos. There's really three, but I'm going to show you two different ways to use Desmos to solve this. All right, so let me stop sharing that and then let me go to Desmos. Okay. So what you're going to do is one way to solve any equation is to simply type the equation exactly the way it is. So negative 4x squared minus 7x equals negative 36. If you do it this way, what you're looking for is the solutions are vertical lines or solution if there's only one. So again, the biggest thing with Desmos is to always kind of know what you're looking for because anybody knows how to type these things into Desmos, but the key is, do you know the math well enough to know what you're looking for? Because if we solved this, our final answer would be x equals these two different values. And when you graph x equals, they're vertical lines. So if you go to the vertical lines, one of my answers is negative 4 and the other one is 2.25. Hopefully we all know what that is, but if we don't, quick way to do that is so if you click that, it'll do the point, and then if you just paste the number and then hit this fraction button, it'll convert it to a fraction for you. So again, that's just to show you there's some really powerful things you can do in Desmos. So again, sometimes students will, when using like the regular calculator on the old SAT or even on this, they'll get the answer in decimal form, and then they'll see all the answers are in fraction form, and then they'll start checking all the fractions to see which equals their decimal, which again is a lot of extra work. So use this feature. Just this changes it to a fraction automatically for you. But again, 2.25 is one where you might just know. All right, so the answer's B, 9 over 4. But what I want to do is show you another way to do this. So another way to solve these, and again, this one I would have just done that way, but this is again to go over all the different ways because in some problems it might be better to do this. So another thing you can do is imagine that the equation is equal to 0. So we would have to bring that negative 36 to the other side. So you would get this. So you get negative 4x squared minus 7x plus 36. Just graph that. So what you're really doing is you're graphing a quadratic that's equal to 0. So you're finding its zeros, which are its x-intercepts. So again, notice that obviously the x-intercepts are the same. So the 2.25 is the one that we're looking for because the other negative answer isn't there. Okay, so if an equation is already equal to 0 or really easy to make it equal to 0, then you could just do this. You don't even have to put y equals or equal to 0. You just put it in that way and you're looking for the x-intercepts. Or just put the equation in as is and look for the any vertical line would be the solution. Okay, so let's jump back to the problem. And we now know that the answer is 9 over 4. All right. So another way we could use Desmos, which these ones we absolutely should, is for systems of linear inequalities. All right. So if you remember doing this in school, the way you would have done this is you would graph them. There really isn't an elimination or substitution method for inequalities. There's really just graphing, and you would sketch it out on graph paper and probably use colored pencils, and you would use two different colors, and then the intersection of those colors would be our solution. So we're just going to use Desmos to graph this. So the way we do this with a system, and also what we're looking for, they do this too. They try to just mess with you by changing the letters around or using new letters. They're saying what's the minimum possible value of A? Well, A is in the position of X. So when we go to graph this, all we're looking for is what's the smallest value of X that we could have. So let's remember that when we go to Desmos. Okay, so if you open this thing up down here, this is how you get your inequalities and some other stuff that you might need. So y is greater than negative 6x plus 1,300. And then the other one is y is less than or equal to 4x. So now another thing, you want to make sure you can see everything. So just kind of like zoom out. There we go. Okay. So the one line we were graphing, the gray is the solution region. The other one, like the lighter red is. So the combination of colors, the double shaded region, that's what we call the solution region. And the problem wanted to know the smallest value of X. Well, what I need is just the intersection, all right? Because if you notice the smallest X will be the leftmost value, and that's going to be the X value of the intersection. Right? The way they word these, it's going to be related to the intersection. Because like if they said rightmost value, that would just go to infinity. So the question wouldn't even make sense. So just also realize they have to ask these questions in certain ways that you can actually do. So if you're graphing these, you're going to be essentially looking for the intersection, and it's going to be the X value because of the way they labeled it. They put the A in the X position. So the answer would just be 130. So let's go back to that problem. So we would just put 130. Okay. On to our last problem. This one is a really good one to use Desmos. Again, you can do it another way, but I really want to focus on Desmos here because there is something that you can use in Desmos that's useful. It's called a slider. So again, I don't know. Sometimes students are very familiar with this, and other times students aren't. It depends how often your teachers are using Desmos in school. So what we're going to do, and also understand that Desmos can be really helpful, but it's not really necessarily, it's not like a substitution for like having to know the math because you have to know when you use Desmos. The key is you always have to know what you're looking for. All right. So anybody can type this stuff in and graph it, but it's like, do you know what you're looking for? So we're going to put this system in and we're going to remember that we want to know what the value of B would be for the system to have no solution. So just a quick reminder of systems of linear equations. You have three options. The two lines are either going to intersect, and if they do, they're going to only be able to intersect once, and you're going to have one solution. So we don't want this. The other option is what we do want is no solutions are going to be two parallel lines. So you're going to get no solution. So if you have lines that never intersect, then you have no solution. The other option is if they're the exact same equation, so you graph one and then you graph the other and it's directly on top of it, then you would have an infinite number of solutions. So knowing that we want this case for this problem because it says no solution, you could use that. Parallel lines have the same slope. So there is a way to do this more algebraically. We also could kind of use the elimination method and do it that way, but we're going to use Desmos. So here's how we're going to do it. I'm just going to type that into Desmos. So you get rid of these from the last problem. If you hit this little home thing, it'll recenter it, bring everything back to where we want it. So first one, I'm just going to type it in as is. So 5x minus 4y equals 12. And then the second one, I'm going to put it in the way it is written. So bx minus 12y equals 12. So it says anytime you type in a letter that's other than x or y, because Desmos is only going to recognize x and y when graphing because of the x-axis and the y-axis. So what you're going to do is anytime you have a letter other than that, you can add a slider. So we're going to add a slider. The point of the slider is to manipulate it and see like what happens with the different b values, right? So in school, your teacher might do this to kind of show you like what's happening. Even though it's called a slider, I would not use it for the slider functionality because I don't know. I feel like you're just wasting time. And some of the answers, a lot of the answers aren't even between -10 and 10. Well, I guess two of the answers aren't. And you can change that. But again, that's kind of wasting time. And some problems, there might be like 2.75 might be one of the things. So like we can't even really do that unless we change this, like how it's like we change its like step size. But we don't need to do any of that. Just realize you don't have to use it as the slider. Just type in the answers here. So the slider is really good for problems that are multiple choice because we have values that we can plug in for the constant. So what we're going to do is we're going to just make b -15 because that's the first answer choice. And again, none of this makes any sense if you don't know what you're looking for. No solution problems are parallel lines. So this is clearly not the answer. And then I go -5. That's not the answer because there's an intersection. Then I go 5. That's not the answer because there's an intersection. So then clearly the answer must be the last one. But we can see when I type in 15, that's the one that gives me parallel lines. Okay, so you can use Desmos here to really save time, but there still isn't like a shortcut for knowing the concepts. All right, so you have to know if it were an infinite solution problem, we would do the same thing. We would have just been looking for two lines that are on top of each other. And if for some reason they asked for one solution, we would be looking for there to be lines that actually intersect. All right. Does anybody have any questions about anything at all? Okay. Well, look out for I'll just show this. If anybody is looking for anything, we have a YouTube. So I will post all the recordings will be posted on YouTube, and I'll share that link when I send out the email on Thursday. We have a TikTok where I'm posting videos there all the time. We have tutoring. We do a whole bunch of other stuff here. But again, the main thing is if you come to all these, it'll at least give you some introduction and some help for the SAT, and hopefully it gives you a better idea of like if you actually need more help or not. Because if a lot of these problems are looking intimidating, then maybe you need to get help either through Khan Academy or through us. But the biggest thing is if you come to these, it'll definitely give you, give you some prep. Okay. All right. If there are no questions, then we'll stop there. So I appreciate everybody coming. So again, look out for my email on Thursday, and I hope to see you all back here same time next Monday.